Hey YouTube, just wanted to do a follow-up video on how I actually built this solar generator. So what I have laid out in front of the table is a couple of items. The battery, 12 volt, 12 amp battery. Like I said in the previous video, it is a sealed lead acid AGM battery because I wanted something that could take a lot of movement and drops and being moved around quite a bit. So went with this particular one, got it off of Amazon, and I will post the links in the comments and on my blog. And what I have here is something that you see all the time. I've seen on a lot of people's builds, the standard marine grade USB port, 1 5 volt 1 amp, 5 volt 2.1 amps that lights up, and you saw that in the other video, cover for it. But what I did is it came with this rubber bushing, but I went to my local hardware store and got this additional steel bushing, so when it goes into here, I wanted to give it more backing. When I tighten this nut on here, to give it some more rigidity, once it's inside of there. And then that's the 12 volt socket there. This is what I was talking about in the previous video. The wire connectors that I have here, this is a 4, there's a 3, and there's a 2 as well. What's nice about these is you don't have to worry about twisting and putting caps on here and a cap's coming loose, or putting electrical tape on there. You can just make your cuts. You strip the wire off and then you push it in. With these are stranded wire, so you had to give it the play with it a little bit to get it in there. With solid copper wiring, it goes right in. And actually, the benefits of using solid is that you can actually wiggle this out, pull it out, and reuse it in case you wanted to disconnect. But with it stranded, you can't. Once it's in, it's in. If you try to pull it out, it just doesn't come out good. And it's actually on the directions on the package that if you use stranded, it's a one and done. But again, I like these. These are in there. Once they're in there, they're not coming out. It's got a mini bus bar in there for your connectivity. And I have several of these, the negative leads. As you can tell here, I was messing around with another negative lead I did not need, so I ended up cutting that out. But then I've got several of those. The charge controller, that again, I spoke about in the previous video. I just mounted that on this piece of wood that I hand cut out freehand. Would like to do that later on with acrylic, and then clean that up a little bit. So just again, I wanted to touch on what I really liked about this controller. It has your standard solar controller, charge controller hookups, to positive and negative for your panels, positive and negative for battery, and likewise for load. You can pull this out, this jumper, to select between sealed or flooded. Really a lot of neat little options for this controller. Again, this is rated for 10 amps at 12 volts, which was exactly what I was looking for, from a size of this particular unit. It does come with, and I would check whoever you're purchasing this from, the 10-L comes with this cover, so you put that on and it covers the terminals, which is great because you don't have to worry about anything landing on this and causing a short or giving you any problems. So if you have any questions about this particular controller, feel free to ask, post your questions, and be glad to give you any input or feedback on what I've experienced with it. I cut these holes here, and I'll show you why here in a few more details, to actually put zip ties to secure this when I set this in the ammo box this way, to secure that to the bolts that go through that are securing the battery. So let me set this guy aside. I have the battery. I already talked about the USB. These are 1/4 inch bolts that I bought online, and I have the links in the blogs. What I did was simply get some heat shrink here, put this over to insulate it, got those on there good and tight, and then bought these 1/4 inch washers so that when I would put this in here and tighten that up, it would give it a little bit more of a seal instead of just flush up against the plastic there. These are the sex bolts that I talked about earlier. Again, I don't come up with the names. Put the same thing, the heat shrink on there and the washer for the other side. And so what you get when you put it through is a nice thread. You screw that in there. It secures the battery in, and you have nothing protruding out from the sides. So that pretty much covers what I have out here, and then I left some of the components in here, the switch, obviously the breaker, the 12-volt socket, and then the powerlet plug, or this is the plug, and then I have the socket over there, and I forgot to bring that up last time. I left it downstairs, but I'll show you what that looks like, and that was pretty simple to do. I have the measurements, and I believe I posted the picture on one of the blogs. I'll double check, and if I didn't, I'll put a link in so you can take a look at where I measured these. Just drilled these out. Let me throw the battery inside of here. And I did do the Velcro on the bottom, and as I mentioned in the previous video, quickly realized that this industrial grade Velcro was not going to cut it, right? It just simply has too much weight. It may work with the lithium iron phosphate batteries because they are so light. I may find out that I don't need to secure that in there. I have seen other options around. What I didn't want to do is I didn't want to glue anything, right? I wanted to be able to take it in and out and swap it out. So I tried that at first and then quickly realized that I was going to need something a little bit stronger. But I have seen other suggestions with different solutions that would give me the same results of being able to move it in and out. So slide that down in there. It pretty much sets right onto the Velcro. It won't slide. So what I did there is then just drilled my holes. I did put some electrical tape just on top of here so that give it I can actually used it for a visual for lining up and just double checking. I did a lot of triple checking of alignments before I did any drill outs on the box to make sure I had it all aligned there properly. And you have to accommodate for that Velcro, right? Because that Velcro does lift the battery up just a little bit. So keep that in mind when you're measuring. So I slide this through, put the other bolt in there, or I'm sorry, the nut, and then secure that in there. Likewise on the other one. And again, the main reason I did this, I really wanted to make sure that this battery would not move because I knew this little unit was going to get moved around quite a bit and utilized for different things, inside, outside, thrown in the back of my truck, taking camping, power loss, whatever. Again, just make sure that you cover enough of these so that you're not leaving any metal exposed. I've gotten some feedback from people, saying, well, you really didn't need to do that, or everybody's got opinions. I'm overly cautious because those of you that do know me, stuff happens, and I'm always that guy that stuff happens to and it breaks. So let me turn that there, got that in there. Battery's not moving. Again, you don't have to crank these really tight. What happens is you start squeezing this box. Remember, this is not very rigid plastic, so no need to over tighten this. And I haven't had an issue with them coming loose. What I was planning on doing was using a little bit of Loctite once I got these where I wanted them, just to keep them from coming loose. But again, I've been taking this thing apart and putting it back together so many times. I wanted to leave it that way for now, and then once I'm happy with it, because I want to recut these and get these wires a little bit cleaned up before going, making this permanent. So now that I have that in there, the next thing I wanted to do was mount this. I was thinking, well, I can go this way, but then I get these not very convenient runs on the wiring. This way made much more sense because this end was closest to the battery. To the load, and I was doing the runs that way. This lined up better from the solar perspective, but I ended up just, this way worked out much better from a wiring perspective. So again, when you set this in there, it might be a little snug, again, because, I over tightened this a little bit. So let me loosen this up. Okay, now that I got this down in there, I'm going to tilt this down, get a better shot of that. And again, I just measured this to line up with those bolts, and I will run the zip tie down in there just to kind of get that nice and secure in there. So what this is down here, this is the positive negative coming from the powerlet socket. And on that note, I wanted to show you, which I neglected to do in the first video, the powerlet plug. So this is the plug. It is water resistant. Once you get it in there, you can just run your positive negative, and I just got that in there, terminated it, and then secured that in there, and then got this piece of shrink wrap, and then heat shrinked it up on there to keep it, the wires from coming apart. Then I put these Anderson power poles on here so that I could switch out different power sources when I was testing this. So it comes in really handy if you haven't messed around with these. These are great to have, so you don't have to constantly connect, disconnect wiring if you're testing, and then whenever you're satisfied with what you're going to go with, then make your permanent connection. So real simple. You lift this up, push this in there, and you hear that little snap there. Pull it out. It's sealed in there pretty good, won't come out. And then I just connected this run to the solar panels when I was doing my testing, and the 12-volt power supply that I have for my testing. So go to their website. You can take a look at some of their other solutions if you're interested in this. Again, it's vertical right now is the motorcycle market. But again, if my use case, this can take a 12 volt, 15 amps max, perfect for this setup. When I was just looking for 12 volts at 10 amps. So let me set that aside. And then going back to here, I have those coming in, so that's what I'm going to connect here to positive negative on the solar. So the one thing I found is, when I was drilling these out, and I have the measurements for these as well, what I will do is give a suggestion here. It might be hard to pick up on the camera here at the angle, but a buddy of mine told me, I said, boy, I was having a hard time, drilling these out for these sockets, and he said, yeah, well, what you want to do is you want to start it going, forward, and once it starts, then actually put it in reverse and then push down, and you'll get a much cleaner cut. So it works really well on plastic. I haven't tried that on wood, but I'm going to do that on the next build. What I want to do is make this exact same build, but with the with the lithium iron phosphate batteries. So that'll be my next project. So with that in mind, my recommendation is that you put, as you're assembling this, start from the bottom. I put the powerlet socket in, connected these up, and then I'll wire these in to here, and then you just can build up, coming from bottom to top. It's just a lot easier when you're working around in here because it does get pretty tight. And then, as I mentioned in a previous video, I have a 10 amp inline fuse on this, and this is nice. You can swap it out with higher or lower. I think this is just an automotive one that I have here. I do have a request for a all marine grade unit, so I'll have to swap this out for everything to be tinted. So that's that, and then I'll forego you the watching me wire this in, and I'll come right back and show you this already ready to secure, and then we'll move on to the next one. Okay, so now I have the positive negative connected in from the solar input from the power LED socket into the controller. The next thing I want to do is add the positive negative connections from the battery into the battery connection of the charge controller. So what I wanted to do in this particular configuration is I wanted the on-off switch to be directly in line with the battery, so I could just cut the power source. So if I turned it off, I shut the controller off, shut the loads, shut everything off, and I wouldn't have to worry about individual switches connecting, controlling various components of this configuration. That was my preference. I just wanted to make sure that if I needed to cut power, I could do it here and it would shut the whole unit down. So what I'm going to do is I'm going to wire this up so the positive comes in, goes to the switch, then goes to the breaker, and then from the breaker it goes into the solar charge controller. So why is that? So in case the load for whatever reason is drawn from the battery exceeds 10 amps, this breaker will kick and not overload the controller itself. So it'll stop that from occurring and offers another layer of protection. So let me stop here and then I'll wire this up, and then I can go over it again just so you can see how the wiring is configured. Alright, so now that I have the battery set up on the positive side, right? So let's just go over real quick what we're looking at here. So what I did is I have the lead, which I'm going to leave disconnected right now from the battery. So just imagine for right now this is coming out, going into the switch. On this side for this particular switch, this is the supply side, how it's labeled, and then this is the load, and then this goes in line with the breaker, comes out, and goes in to here. So again, the reason I did this is so that when it draws power from the battery, if we're exceeding 10 amps, then the breaker should kick in so we don't overload the battery or the controller. So then from here, what I will do is bring in the negative side. So I have the negative connections here. I actually have two sets. This set is for the loads that the load side negative leads, and then this is the negative connection going to the battery that I will connect to the switch, and then also to the charge controller. So let me get this negative side connected now, and then I'll come back and then we'll jump over to the load configuration and how I have this wiring set up, and then we'll wrap it up with putting everything else together and just do another quick overview. So now I have that wired in. This is that negative lead, and this is why for me, I mentioned this in the previous video, I wanted to redo these lengths because this was all configured for a different controller, as I mentioned before, and I had the wires all configured and nice and neat for that particular controller, and it didn't work out. So that's definitely on my to-do list before I deem this project complete. So what you're seeing now is I have negative coming out, going into that 3 connector wire connector, the negative coming out from the switch, and then feeding in to the controller on the negative side of the controller. So now what I should do is turn the switch on, the battery the controller does a self-diagnosis there, and I'm good to go with a good charge. So let me turn that off. And the next thing I'm going to do is start connecting all of my the loads, right? So the USB, the 12 volt socket, and then get my positive and negatives into there, and then finally put the terminal cover on there, and we're all set. So I'll be right back, get that all configured, and we'll wrap this up. Okay, now I have all of the leads connected in, and you can see that it's really tight in here. Definitely going to be redoing some of the lengths of the cable so that it's not, as you can see here, it's entirely too tight with all those in there. Just not comfortable with that, but it does work, which is good to know. I mean, we can just turn the switch here. We got power. It does the self-diagnosis, battery charges right there. We can turn this around, take a look, LEDs lit up. Get that turned a little bit here, straighten that out, and that's about it. The last thing we need to do is put our cover on here. As you can tell, look, that's going to be pretty tight because of we have to line all this up. Get this down in there, and then place our screws. And by the way, when you go to do this, there's already 2 screws that are on the unit, on the charge controller itself, so you're going to have to back them out. Actually, what I'm doing is going to shut the power off. Get those screws down in there, get that terminal cover down, and we'll be all set. So hopefully you found this helpful. I didn't want to, I wanted to show real quick how to assemble this. Turn that back on. Cover's on. We got the whole thing set up. If you have any questions and how I got anything in here, where I found these, I'm going to go through everything that I've posted so far, make sure I've got all the details in there. Some of the things most of the items here I was able to get on Amazon, but some things had to go local. I still have to put the zip ties in here to get this securely on here so this doesn't slide out. And that would be the last thing. And then the lid, what's nice about all the ammo boxes is that the lids just come right on and off to get out of your way. Snap that down, latch this shut, and you're good to go. So this concludes this video here. If you want me to do additional ones and teardowns or measurements or whatever, please let me know. Thanks for watching. Please subscribe, ask questions. I've got a couple other things that I'm working on next, and I mentioned some of it in the first video. I was traveling and I took my portable USB solar panel, so took a bunch of pictures of that, and I'll put together a video on some of my findings. They're pretty interesting on some cables I brought with me to see if I was getting any different outputs from the panel, and what happened when I tried to do it indoors through tinted glass. So okay, thanks again for watching. Please subscribe, comment, post, share, whatever you guys want to do, and I'd be glad to help. Okay, thanks YouTube.